Hi, everyone. Thank you for joining us for today's webinar, Confident React with Kent C. Dodds. Kent needs no introduction, but I'll give a short one anyway. Kent works at PayPal as a full-stack JavaScript engineer and has been actively involved in the open source community. He is the creator of testingjavascript.com, and he's an instructor on Egged.io and Frontend Masters. He's also a Google developer expert. In addition to all of that, Kent is also a sought-after speaker and has talked at leading software conferences across the world. So with all that, I suggest we let Kent do the talking from now on. So Kent, take it away.
Thank you so much, Eddie. So hi, everyone. I can't see you, but you can see me, hopefully. Thank you for trusting me with the next hour of your lives. Hopefully you don't leave early. We're going to be talking about Confident React. Specifically, I'll be giving examples of React testing library. And this is specific to React, but there are going to be some elements of what we're talking about that really apply to just about anything. I'm going to talk a lot about testing philosophy and that kind of thing. So anyway, this is a bunch of stuff about me. Each one of these things has a link associated with it. So if you're unfamiliar with what these icons are, you can find my slides at kcd.im/confident-react and find out what all these things are. So typically when I give talks, I really like to start out with some calisthenics, but as we are remote, I am not going to ask you to do that. Your coworkers might look at you funny, and I don't want that to happen. So after we're finished, go find a quiet place where you can go do some exercise, because that's really important. Okay, so I like to start my talks out with some expectations so that we're all on the same page. So this is going to be a discussion of how to test web applications effectively. Like I said, the examples are React specific, but we're going to be talking more generally, broadly, testing principles with regard to front-end applications. And it is a little bit of a pitch of a testing library that I wrote, but like I said, primarily it's let's think about what we can do to be confident in the tests that we're writing. So this talk is not going to be a discussion of functional or end-to-end testing, not directly anyway, no examples for those. And yeah, hopefully it's not boring. Okay, so with that out of the way, let's go ahead and get ourselves started. So first I want to pose a question. Why do we test our software? So why do you test your software? Are you testing your software? Now, I know that many of you are likely software or test automation engineers, but for many software engineers, we test our software as a workflow enhancement. So it helps us, we do test-driven development and we test drive the development of the software, and so it enhances our workflow, helps us be faster or more precise, find problems and issues faster. But as test automation engineers and as a software developer, I'm mostly interested, when I'm testing, I'm mostly interested in confidence that my application is working properly. So this can have, these kinds of tests can be tests that I wrote as I was doing test-driven development, or they can be tests that I write after the fact. But in either case, I'm mostly interested, at least the test that I commit to our source control with the repository, I'm mostly interested in the confidence that these tests can give me. So with that in mind, what kind of tests give us the most confidence? How do we get the most confidence out of our tests? Well, there's this principle that some smart person once said. It is the more your tests resemble the way your software is used, the more confidence they can give you. That smart person was actually me, so I just called myself smart. But I believe this principle really firmly. If you also believe it, you can go to my slides and click on that. That's a tweet, and you can retweet it. But I don't think that there is any deviation from this truth. The closer that your tests can resemble the way the software is used, the more confident you can be. So with that in mind, what kinds of tests can give us the most confidence? Well, the way my software is used is what my goal is for my tests, then maybe I should just manually test it the way my software is used. I just do exactly what the user is going to do, which is sit down at a computer, open up their web browser, like Google for my website or navigate to my website, go through the login and click around and do all of that stuff. That is how I can find the most confidence that it's going to work when user Bob goes and does the exact same thing. So that's where we can get the most confidence, but it's not really a scalable solution for testing our software, because there are so many permutations of our software that any change that we make before we ship to production, we want to make sure that we're confident in shipping. If we were to go through manual testing, then it would take us a very long time to ship anything, and it might kill our business. There actually was one company that I worked at where this kind of was the testing strategy, and we had this whole application that was written so that we could pick different task or test scenarios, and we'd manually go through this huge backlog. And so everybody at the company, sales, marketing, the test automation, or the test engineers were responsible for making these specifications, and then even the software developers as well. We'd all go through these things, and I'll tell you what happened was I would, and I hope that I'm not the only one who's this bad of a person, but I assume that other people did this as well. I would go through the steps and something wouldn't look quite right, and I think to myself, oh, that was probably just a fluke. Maybe the database had extra load or something. I don't know. And I would just say pass, because all I wanted to do was get back to my actual job. I didn't want to do that manual testing. So even though manual testing gives us the most amount of confidence that we could possibly get out of our tests, it's not a practical way to do it, and it's subject to human error and human weakness. So that's not going to really do it for us. So how do we overcome these human shortcomings? We automate it. That is where, in the history of software development, manual testing came first, and then we were like, hey, there's some problems with manual testing. Let's write a program that tests our program. So automation is like the key to solving all of these problems. It's faster, and it doesn't say, oh, well, that was probably a fluke. It is just a better way to test our software. But it's really important in the process of automating our testing of our software that we don't throw the baby out with the bathwater, so to speak, by taking that guiding principle of our test resembling the way our software is used, by like testing implementation details of our software. And that's where I'm going to focus most of my time on in this talk today. So let's talk a little bit about trade-offs really quick. If you haven't been in the software world for very long, this might not be familiar to you, but it's a pretty popular way to talk about the different layers of testing. And I'm not going to go too far into depth between the distinguishing characteristics here. I do have a talk called What We Can Learn About Testing from the Wheel, where I talk about the different distinguishing characteristics. It's 5 minutes long, so you can Google that. But yeah, so let's talk about these trade-offs. So end-to-end testing here at the very top it's automating a browser if we're talking about the like a web application, and it's trying to do exactly what the user would do in our application. So typically it'll load up the whole application, it'll go through the login flow, it'll go through the checkout process or whatever we need to do. And so that one's pretty close to the user's experience in our testing. And so if we want to get the most confidence that we can, then we'll go with our end-to-end test. But you'll notice it's the smallest triangle up here. And I'm going to address that here in a little bit. So then integration tests, we're going to kind of go down the stack a little bit. We're trading off our test resembling the way our software is used for a little bit more feasibility. And then unit tests, we're going down even further, getting further away from the way that our entire application is used, down to a specific small piece or atom, I guess, of our software. So when we look at this testing pyramid, often we'll see these two arrows indicating the trade-offs that you're making. So here at the bottom, our unit tests are super cheap to write and to run, and they're super fast. They run really quickly. So that's a really nice thing. But the further up the pyramid we go, the more expensive it is to maintain and write and run, and the slower they are. They also tend to be more finicky. There are more points of failure. And so if you just look at those two aspects of the testing pyramid, you might think to yourself, well, goodness gracious, why don't we just unit test everything? Unit tests are cheap, unit tests are fast. And anytime I've seen this testing pyramid, there is one aspect of this whole concept of testing that has always been left out, and it's really bothered me. And so I decided, hey, this testing pyramid was created years ago when end-to-end testing tools were not super great as they are today. And so maybe this testing pyramid can take a new shape. And so I came up with the testing trophy. So the testing trophy still has the same ideas here. We have end-to-end integration unit, but then I also added static. So in particular with JavaScript, other languages, there are many other languages that are statically typed. And so that's just like the default. Is like, how could you not write Java that's statically typed, right? But in the JavaScript world, that's a tool that you have to add in. So you're going to add TypeScript or flow type to add static typing to your application. And so that's something that I've added to the testing pyramid. But then I changed the shape of it, because while these two arrows or these two principles or elements of this testing shape are true, one thing that was missing from the testing pyramid is what I call the confidence coefficient. So what that relates to is the closer or the higher we go up the testing trophy or the testing pyramid, the closer we're getting to our tests resembling the way that our software is used. And so our confidence, the confidence that we get from those tests, also goes up. So if the test is passing that says that this function called add returns the sum of two numbers, then that's great. And that gets me confidence in that one little function. But I've got thousands of functions in my application. And so if instead I have a test that goes through the checkout process and the add function just happens to be used in, where we're summing up the totals, then I'm getting coverage for that add function in addition to the fact that the whole test or the whole checkout flow works properly. And so that helps me solve those bigger or catch those bigger problems that are more important to my application. So I can be more confident that my application is working with these end-to-end tests than I can with these unit tests or with static typing. Now there are these other elements of these different forms of tests that are actually important and do take, or you do need to take into consideration. But that's why I have found that integration tests, particularly UI integration tests. So I'm not talking about services talking to each other as an integration. I'm talking about your front end code. This component renders this one, all these components working together. That is the type of integration that I'm interested in testing. I'm not interested in unit testing a little button component that renders a button with a class name or something. That doesn't feel valuable to me. I'm going to get the most bang for my buck out of integration tests. So with that set and framed, let's go ahead and look at a specific example. So we've got this application, Today I Learned, and it has a login. So I clicked on this, or actually here we're on the registry page, but the login and registry page actually look identical, and they're using the exact same code. So here on this login registration form, you can provide a username and a password. You click submit, and you're logged in. So how would we manually test this? If I were a manual tester, I would go in and I would type in a username and password that has been preloaded into the database or something. I would say, okay, I've got this username data. I need to fill it into this form. So how do I do that? I'm gonna go find the field that's labeled username and put in the username data. Then I'm gonna find the field that's labeled password and put in the password data. Then I'm gonna click on the submit button. Okay, great. So that's how we would manually test this. And if we're interested in getting confidence out of our tests, regardless of the level that our tests are written in or focusing on, we're going to try to resemble that experience as closely as possible. In particular, one thing that I'll just mention here is if the password and username are swapped, then I should still be able to fill in this form properly. I should see that, oh, password's first, username second. Maybe that's actually a bug, but I should still be able to pass this test. So, or if we add a checkbox in here somewhere, that shouldn't change whether or not my test is passing. At least it wouldn't when I'm testing it manually. So my automated test shouldn't fail either. So this is how we're going to manually test it. Let's talk about how we're going to take the benefits of that resemblance into some automated tests. So we're going to skip over the end-to-end test because I'm mostly interested, in this case, I'm just going to test this functionality right here, just this form. So let's talk about the state of the art for testing React applications or React components. First off is a tool called Jest. If you have not heard of Jest before, it is a fantastic test runner. It's actually more of a testing framework. It can do a silly amount of things. It is super useful. I've used every testing tool that has any amount of usage in the broader JavaScript community, and Jest is by far my favorite. I've been using it for a couple of years. I have no interest in using anything else for unit and integration tests of my JavaScript. It's fantastic. It's actually so powerful. You can even run ESLint, you can run Mocha, you can run even Python tests with Jest. It's really cool. So with React components, we typically are running our React components in the browser when we ship our application. But we're going to make a trade-off here because loading up an entire browser and running through all of our tests, there are some limitations with that with regard to performance and like the running of our tests and the capabilities of mocking out modules and different things like that. So Jest runs just in Node, and it uses a module called JSDOM to simulate a browser environment in Node. So it's all running locally on your machine, not in a browser. This does come with some heavy trade-offs. So if you want to do some really complex, test some really complex code that's doing like layout measurement and DOM, it's mostly layout stuff, then you're going to want to move those, test those components using Cypress, which I'm not going to have time to talk about today, but it's the other half of the puzzle for me. When I want to run tests in an actual browser in an environment that JSDOM isn't capable of simulating. So that's the state of the art there. And then most people, the state of the art is changing thanks to my library, but most people still are using Enzyme to test their React components. So we're going to look at some examples using Enzyme. Okay, cool. So here is the code for our form example. We're going to kind of look through some of this. So we've got React on the page. We've got this login function component. We have this form function, that component that takes an onSubmit handler and children. It just renders whatever. And so our login is using that form. And when the submit event is fired, then it's going to just forward that function on to whoever's using login. So we have the actual login form when somebody has an existing account, but then we also have registration. And so they're each going to have a different submit handler based off of their use case. So what we are interested in testing is this login component here. So it's composed of that form, and then we have this labeled input that gives us a label of username and the default type is just text, and it'll render out an input. And then we have a labeled input for the password where the type is password, and it renders out that password for us. And then we have our button, and and then we have our handler here. So that's pretty much it as far as this little component goes. So let's look at a couple examples of what the tests actually look like for this. So if we go here in our project, by the way, this is using a tool called codesandbox.io. It's fantastic. So if you, when you look at the slides later, you can click on this link and that'll take you to the code sandbox and you can play around with things. So here we can go to form.enzyme as our enzyme example. And with enzyme, we use enzyme and then the adapter for React 16, and then we configure it. And then from there, we can write our tests. So let's take a look at our test. Now, remember, the most important thing for us to do, or our goal here in getting confidence out of our tests, is for our test to resemble what what the user is actually going to experience when they're using this component. Now, here we're going to use the mount method from enzyme, and that is something our user cannot do. The user can't take a component and mount it. That doesn't make sense for the user. They're going to navigate to a page. And so this is where the trade-offs come in, where I'm saying, okay, we're going to lower or we're going to trade off the resemblance of how the user's using this in this particular instance so that we can focus on just this one component rather than rendering our entire application. And so that's what we're doing here is we're making that trade-off. We're conscious about that trade-off and we're okay with that because it allows us to focus our test around a particular component. So in this case, we're going to mount this component with enzyme, and that is basically going to take that component and render it into the document. And we're just going to pass this login with a fake submit handler because when the user clicks submit, we want to make sure that that submit handler was clicked. And enzyme gives us back this wrapper, and all we need is to get access to the DOM node so that we can set its value. And so we do all this stuff, which is kind of weird, but this is what you have to do in enzyme to get the DOM node. Don't hurt yourself over thinking about this too much because I'm gonna show you something that's a lot better here in a second. But the idea is we want to get the DOM node for the username input and set its value to Chuck Norris, of course. And then we'll do the same thing for the password input and set its password to I need no password because it's Chuck Norris. Goodness gracious, the password needs Chuck Norris. So then here we're going to find our form component that we rendered and simulate a submit event so that we can make sure that our handle submit was called and that it was called with the right data. So that is what we're doing in enzyme. And let's talk about a couple of the problems that we have with this particular test. So first of all, what I'm mostly interested in when I'm talking about testing and worried about implementation details is you need to ask yourself the question, can I run into false positives? So it's failing, but it shouldn't be. And can I run into false negatives where it's not failing and it should be? And I think I switched those, but false anything, don't get false stuff. So false positive, false negatives. So yeah, with false negatives, it's failing, but it shouldn't be. That can happen when you're testing implementation details and you change the implementation. So everything works as far as the user's concerned. They don't even know that you're using React. Like you could be using Elm or Reason or Angular or whatever. It doesn't matter to the user what you're using to render stuff to the page. Goodness, you could be using Flash, and if they have it enabled, it should still work, right? So to the user, it doesn't matter. That's all an implementation detail. And so if you change an implementation detail, it should not necessarily change the way that the user experiences your component. And in the context of these integration tests or these unit tests that we're writing, our user includes the developer user who will be rendering this login component. So like the API of this login component shouldn't change, and what it ends up rendering, so long as the user can still use it exactly as they were before, then everything should be fine. And so if you go through a refactor like that, and your tests end up breaking, That's because you were testing implementation details. So what are some things that we can do in this login component that could break our tests? Well, one thing we could do is swap the password and the username. Now, it might be a little odd, but that could break the user's expectation. But that will definitely break our tests. Another thing that's maybe a little less odd is we could add another labeled input here that is a favorite ice cream, whatever. Like you can see how there are things that we could add to this particular form that we're rendering that could change the expected, or that could not change the expected behavior of the form. We're adding some feature, but will actually break the tests that we've written. So that's one thing that bothers me. Another thing that actually this is even more arduous is that Enzyme provides these APIs that really encourage you to test implementation details. So wrapper.find allows you to find by a CSS selector, so we're finding an input, but then it also allows you to find by a component name. So a refactor that we could do here is I could just rename this to my form. We'll go to my form and rename this to my form. That should not break anything. The user doesn't know about the my form function. We're not exporting this, so no developers even using it. We've updated, totally refactored, and poof, our tests have broken because this wrapper.find form, it's not going to find it. So the fact that Enzyme allows these kinds of tests to be written was really bothersome to me, and I wanted to get away from that. And so I was actually creating a workshop where I wanted to show people how to use Enzyme. It was a testing React workshop, and Enzyme was the thing. And so the way that I do that is I actually start with the fundamentals of like the raw APIs. So under the hood, when you call Enzyme's mount function here, it's actually going to use React DOM, and it'll use React DOM.render. And so that's what I started out teaching. I said, okay, well, let's create a div element. We'll render our login to that container, and then we'll do the same thing. We'll get our inputs. So here are all the inputs. We'll get the first one. That'll be our username, and we'll set its value. The second one will be our password. We'll set its value. And then we'll simulate a submit event on that thing and verify things are working as expected. It's calling our submit handler. And so then I was stepping into Enzyme, and I thought, okay, well, now I've got to go through this giant list of all the APIs that Enzyme allows, like getting the state of a component and being able to assert on that state or set that state, which is totally an implementation detail. Users don't know what the state is, and developers don't actually access the state themselves from outside of the component. Or getting the props that you've passed to a component. That's also an implementation detail. So there are a lot of implementation details that Enzyme allows you to test. And so when I was thinking, okay, let's teach about all of these things that you shouldn't use in this tool that I'm teaching you to use, that really bothered me. And so that's when I said, hey, this actually looks pretty simple. I bet I could write my own. And that is exactly what I did. I created React Testing Library, and this is what React Testing Library allows you to do. So it has a render. You render out your the component you want to render, and then you get back an object, and we're just destructuring the properties off of this object called get by label text and get by text. So what's really cool about this is with get by label text and get by text, I am doing exactly what the user is going to do. My test now actually resembles the way that my application is going to be used, because the user doesn't look for the first input and the second input. There could be an extra input like an optional name or like a checkbox for just about anything, or there could be any number of inputs. User doesn't care about those. The user cares about the input that's labeled username, and so that's what my test should care about. So I'm going to get the input that is labeled username, and then I'm going to set its value. And then I'm going to get the one labeled password. I'm going to set its value, and then I'm going to click on the submit button. Before, we were firing a simulate or firing a submit event on that submit on that form, because that's how you do that with Enzyme or even with React DOM. But React Testing Library created this fire event that will fire a browser event on this by clicking on the submit button, and that, because it's all wired up properly, will actually submit the form. And so with these, both of these implementations, we could actually break the implementation by removing the submit button or by having a typo in submit, and now the user clicks on submit and nothing happens. So I'm a lot happier about doing what my actual user is going to do in my test, making sure that if I do that typo, it's going to break. So we're going to click on that submit button, and then our assertions are exactly the same as they were before. But our test resembles the way that the user is going to use our application. And that's the most important piece of getting confidence out of your tests. So I'm just going to show a couple more examples, then we'll wrap up and be ready for questions. Oh, actually, let me first show you React Testing Library, then I'll show you a couple more examples. So here are a couple of the things that you get from React Testing Library. So you get the render method, a fire event method. Well, it's a fire event utility. Cleanup method, so when you render, it actually puts it into the DOM. The cleanup is going to just remove everything from the DOM. And typically, you'll just set up that in some configuration somewhere and make it all, and like you don't ever have to really call that. And then we have a bunch of asynchronous methods here. So if, and I'll show you some examples of this, but we can wait for an element, or wait for any DOM change to happen. And then flush effects. This is something specific for testing the use effect hook in React, which is an upcoming feature in React that is pretty sweet. So you can go look into that. From render, this is the method you're going to be calling most of the time, and here are the things you get back from render. So you'll get an object that has these properties: the container where your element was rendered into, a re-render function if you need to see, oh, I want to change the props. Let's see what happens when I change the props. And then a whole bunch of others. Unmount, I put container in there twice. I was testing you to see if you caught that. No, just kidding. That was a mistake. The base element, so that's where the queries are going to be loaded onto. And then debug allows you to, it will actually console log a formatted and highlighted rendering of what the DOM looks like. And as fragment is just some extra thing you can look into the docs, what that's all about. But then we have get by label text, get by placeholder text, which is not as accessible. You should have a label for your elements, but if you don't, then you should at least have a placeholder, and you can get by that. I should add here that one of the big benefits of using React Testing Library is that all of a sudden you can't test things that are inaccessible. So what that means is you have an input and a label, and you can put that label right next to that input, but a screen reader is not going to associate those two unless you associate them with one another by giving the label a for and an input the ID, or an aria labeled by. So people, when they start adopting React Testing Library, they find out, oh, I do get by label text, but it's not finding my element. And the reason is because their label was never wired up to the input properly anyway. And so it's been really fun to watch people's applications get more accessible when they realize that, oh, I can't test it unless it is. And so that's, you kind of get automatic accessibility testing by using React Testing Library. And then we have get by text, which is good for getting buttons, get by alt text for getting images, and get by title for SVGs, and display value. So that's like getting the select or getting an input or whatever is there. Get by role, so get the modal or whatever, and then you can query for stuff within the modal. And then we have an escape hatch called get by test ID, where you can specify a test ID, which is actually, if you're using like lots of end-to-end testing, typically recommends using test IDs to find things. It's way better than using class names, which can change because we want to style things differently. And so we have this escape hatch. It's not as good because it technically is an implementation detail. The user can't see these test IDs, but it's better than the alternative of using class names. So let's look at another example. This is async. This is always something that people struggle with when testing. And so I've got the entire component in here. It's a fetch component. It's using Axios to make HTTP calls. And yeah, that's basically all that we're doing here. I've got a data test ID for this greeting because this value here is not really deterministic. So I want to get something that's more specific. And then here is what the test looks like. So we're going to mock out Axios, however your tool allows you to mock that. Or if you're using fetch or whatever, you're going to want to mock those things out. Your unit and integration tests for UI should never be making HTTP calls. That's what you use end-to-end testing for. And then we'll have our URL and we forward those props along. We render that. And then all we need is get by text and get by test ID. So we're going to get by text to click on the fetch button. It's going to go make our fetch, which will hit this fake Axios thing. And we're going to use the wait for element utility. And so what this is going to do is it schedules a mutation observer within JS DOM, or if you can actually run these in the browser too. React Testing Library works in the browser. And so it'll schedule a regular mutation observer in the browser. And anytime the DOM is changed, it's going to call your callback, and it will continue to do that, continue to observe for changes until either what you've returned is not null and it doesn't throw an error, or you time out, and that ingests the default timeout is 4 seconds. So this might look a little bit like, lots of people will look at this and criticize it and say, that's an end-to-end test. I don't care. I'm mostly interested in my test giving me confidence. I don't think that it really is, like this certainly isn't an end-to-end test. We're faking HTTP calls. So this actually will basically just happen on the next tick of the event loop because we're immediately resolving this promise. But in any case, my test, as far as my test is concerned, it doesn't really care whether it happens immediately or if it happens 2 seconds from now. My test is written in a way that just makes it really easy to read and understand, and it's free of implementation details. So eventually we're going to get that greeting rendered to the DOM. We'll get that greeting node, and then we can make assertions that our fake Axios was called correctly, because anything you mock, you want to assert on. And then our greeting node has the right text content. So that's an example of async. Thank heaven to async await, makes stuff like this look so much nicer. Yeah, with these utilities, it's really quite nice. Okay, so we do have, I'm just about done with my talk here, but there are a whole bunch more examples that I'll just show you that you can go look at and explore yourself later. But we've got async tests, onchange, portals, React lazy and React suspense, React router and Redux, and how to upload a file. All of these things are available at React Testing Library examples. And you can find that right here. So let me just wrap up with a couple things. One thing that I did not show you, I kind of saved here to the end, is because React is actually an implementation detail, and React Testing Library doesn't allow you to test those, most of the utilities the React Testing Library gives you are actually like generally useful for just DOM in general. So we have the DOM testing library. And so any framework you use, however you get DOM stuff into the browser, you can use DOM testing library to test it in the same beautiful way that you just saw. So all of those queries are available. They're actually built into DOM testing library, and the React testing library is actually just built on top of that. It's like a 50-line file that wraps DOM testing library in a nice React-specific implementation. And so because of that, we actually also have Cypress testing library as well. So there's React testing library, Cypress testing library. There also is a Vue testing library. There's an Angular testing library. These docs are coming soon. Yeah, so it's freeing yourself from implementation details means that if you change, like even for your unit and integration tests, if you change the entire framework, then maybe you just switch from React testing library to Vue testing library or vice versa. And then you just update a couple of things in your tests, and all of your assertions should still work. The way that you're interacting with the DOM should still work. It's just how you're rendering that component is the only thing that really changes, which I think is really, really awesome. Yeah, then the last thing that I wanted to show you here is this testingjavascript.com. Let me just switch this over really quick. So right here we go. So this is something, I'm full disclosure, plug your ears if you don't like this, but this is something you can give me money for. But it is a huge workshop that I created and released recently that is based on the idea behind the testing trophy. So if I scroll down here past all the stuff that they wrote for me, I didn't build the website, I just made the content. Then I'll show you what's in this, and you can tell me, or you can decide if it's valuable to you. But we've got fundamentals of testing in JavaScript. So I show you actually how to write a testing framework. We write our own JavaScript testing framework and assertion library. I show you how to set up static analysis testing tools. And I show you how mocking JavaScript works, and how the tools, specifically Jest, how Jest is mocking our stuff, and how to use those things. I have this 1.5-hour course on how to configure Jest for modern real-world applications. Typically, Jest doesn't need to be configured a whole lot. You can do a lot of stuff without configuring it, but in any practical application, there's a lot of stuff that you can do to optimize it. And then Cypress, and then we wrap up with, then we also have specific React testing library course on lots of different situations, including test-driven development, which is really cool because before React testing library, our tools were so focused on implementation details that it was impossible to implement it after writing the test because you didn't know what the implementation was. But now that your tests are free of implementation details, you can actually write the test first and implement the component second. And I show you how to do that as part of this course with lots of other things. And then I show you how to use DOM testing library to test just about any JavaScript framework. There are 11 in here. It's pretty cool. So with that, I am finished, and I hope that this was really fun and interesting, and I'm going to leave this open for questions. Thanks.
So first of all, I didn't see anyone complaining about that thing being an end-to-end test. I did see a lot of personal thank you notes that everyone has been sending you, Kent, via the questions panel. So to everyone, I do promise that those will be sent to Kent. I will send those to Kent after the session. Keep those coming. I won't go over them now. Yeah, I won't go over them now. I want to reserve this time for a Q&A. And one more thing before we do go into Q&A, I just wanted to mention that I put the link to testingjavascript.com in the chat room. So that's available for anyone that maybe, I don't know, needed it, wants it, so it's there. So first question, what happens if your site needs to be translated?
Yeah, I'm glad that whoever's asking this is asking. This is a very big concern with these get by label text and things. So I work for PayPal. I probably should have mentioned that at the beginning. It was on my slide, but I should have said it out loud. And clearly our site needs to be translated. So what I do is I rely on the translators to actually translate things properly. Like I don't check their translations or anything. And I just say, let's load up the English translation in our test environment. So typically that requires a couple of things you do before you load up Jest, and I show you how to do some of those things in my course. So you load up your test environment with the English translations so that everything is rendering English. If you can't do that for some reason, then you're probably using translation IDs. And you just, you'll mock out your whatever library you're using to, instead of rendering the actual translation, it'll just render the translation ID. And then you can say get by label text and provide the translation ID. It's not as good because like somebody could have deleted that translation ID and you don't know. And so that could break things in a bad way. So you lose a little bit of confidence. Anytime you mock anything, you're going to lose confidence. But we mock things to make things practical. So an actual to make things work. And so if that's not something that you can do, then mocking things out and rendering the translation ID works pretty well. And then as an escape hatch, again, there's the test IDs, and you can always just use, in fact, when React Testing Library was originally created, that's all it provided was the test IDs. And then somebody mentioned to me that we could do things a little bit better by using label text and stuff. And now all of my tests look like that. It's great.
Next question. What are your thoughts about TDD?
I think TDD is great when it is practical. So I probably TDD, it's hard to put a number on it, maybe 10% of the time, maybe less. It depends on what I'm working on. So I really like TDD for things that are well-defined. I know what it's going to do. Like if a designer gives me a form and they say, here are the elements of the form, whatever, then I can TDD that because I can see, oh, here's the label, the username, whatever. I can write that test first, and then I can go and implement it. That's pretty easy. But if it's a complex, like, I don't know, drag and drop UI or something that's sufficiently complex, requires making HTTP calls every single time you type, or I don't know, there are definitely situations where I can't see the end from the beginning. And so those are the things that I will not TDD. Something that I definitely TDD pretty regularly are pure functions. Anytime I have a pure function, I know what the inputs and outputs are. Typically, I'm going to write those because I have in my mind, I want something that'll do this conversion for me. And so I'll write out all the before and after states when I like the inputs and the outputs. I'll write all those out. I use this library called just in case. Really awesome library. And with that, I can write out these different inputs and outputs, and then I can go and implement that. That's one case that is perfect for TDD. So yeah, like I said, I don't use it a lot, but there are some scenarios where it really enhances my workflow. One thing that I really like to do, or that I'm starting to get into, is what I'm calling Cypress-driven development. So if you haven't used Cypress before, it's a really awesome tool. You can go cypress.io. And here, I'll just go there right now. And with Cypress, think of it as a replacement for Selenium, but it's so fast and so powerful that you can take, like typically you're going to have your Chrome browser up or Firefox or whatever, and you'll be refreshing the page, or you use a hot module replacement or whatever. You can replace that browser with Cypress because it has all of the dev tools that you're used to using. And then you can write your end-to-end tests to get yourself into a state that for whatever it is that you're writing. So I'm a pretty good, like I like that idea, and that's something that I'm kind of investigating, trying, and adding to my workflow. Hopefully that's helpful.
Okay. Next question. How has been your experience with React and TypeScript, especially from a testing perspective?
Yeah, so anybody who's following me on Twitter knows that I am switching from flow type to TypeScript, and I wrote a blog post about this. If you go to kcd.im/news, that'll take you to my newsletter. 2 weeks after I send out my newsletter, I'll post that to my blog, which is blog.kenseydodds.com. But I wrote this blog post, why every new web app at PayPal starts with TypeScript. TypeScript is awesome because it allows you, so typically when you're writing a unit test for a function, let's say it's the add function, it's really easy, A, B, they're both numbers, you return the sum of both of them. You're probably not going to test what happens when I pass a string to that function, because nobody should pass a string to the function, right? And so you won't even write cases or if statements in there to throw useful error messages if they're passing the wrong data. And so you have actually no confidence that misuse of this function is going to get you, or is going to result in an early error so people don't misuse the function. Yeah, you basically have no confidence. So TypeScript comes along and you add types to that, and you can say, okay, this only accepts a number. And now when somebody tries to use it and they try to pass a string because they think it's a concatenation function, or I don't know, then they're going to get an error, like a compile time error, which is super valuable. So it will catch things that you probably wouldn't have written tests for anyway. And so it fills a really important gap in this testing trophy that was never in the testing pyramid, probably because the testing pyramid was not written with dynamically typed languages in mind. And so that's why creating something new was necessary. So hopefully that answers the question.
How do I write tests that are resilient to backward compatible changes?
So hopefully that was what my talk was all about. But if you want to learn more about testing implementation details, I've got this blog post called Testing Implementation Details, where I describe specifically where is it? Yeah, here it is. Why is testing implementation details so bad? When you can break code when refactoring it, or yeah, your test can break when you refactor an application, or they might not fail when you break the application. And so, yeah, how do you do that? Well, never use shallow rendering from Enzyme ever. I've got a blog post about that too, shallow. Oh, actually, I don't have it as a short URL, so shallow rendering. Why I never use shallow rendering, where I describe how that is like, all that is a big implementation detail. Yeah, and then actually, there's also blog posts, write tests, not too many, mostly integration, where I talk a little bit about this as well, where you can focus mostly or avoiding implementation details. But the idea is avoid implementation details by only doing things that the users of your component can do or will typically do. So they don't access state, they don't set state, certainly, on a component that they're rendering. The user is not going to do those things, and so your test shouldn't do those things either. Hopefully that answers the question.
Do you have any instruction or suggestion on building test frameworks for testing APIs?
I typically wouldn't do that. So typically that's more general, like how do you build abstractions kind of question. And the way that I build abstractions is I build like my first test, and then I'll build another one, and then I'll build another one, and I'll see, hey, these three things look similar. Let's extract those three and the similarities from those three, and we'll make a utility function. And then I build more tests, and I'm using that utility function. I'm enhancing that utility function more and more. And over time, I have, oh, maybe this one doesn't really fit that use case, so I'll make a new utility function. And over time, you have yourself a pretty good sizable utility function thing, and you're going to have if statements and things in there. At that point, you're like, I need something to test my tests because those utility functions are sufficiently complex. They're giving you a lot of value, so definitely that's where React Testing Library came from. I had a couple of utility functions around Enzyme, and I wanted to test my tests. And so you extract that out, put it into another project, you write tests for your testing abstraction, and that's how I go about that. Hopefully that was helpful. It's more general, like if you want to get specifics, like what modules do you use and stuff, I like to use Axios directly. I don't like, there are these different modules that allow you to make assertions when you're saying, hey, this request is coming, and when it comes, it should do these things. I feel like that's more of an abstraction than I typically need, but yeah, anyway, hopefully that was helpful.
How is testing with label text better than testing with IDs?
Because if you test with an ID and then you like, well, actually, if you start testing with IDs, you have no confidence that that label text is associated with that input. So when a screen reader comes around, it's going to just read that text, or it might not even, they'll just go straight to the input and it'll say you're in an input. And that's all it can tell you. And so your application isn't at all accessible, and your test can't verify that. Whereas if you test with label text, then you say, okay, find me the label text. That's what the user's going to do. They're going to look for the label text. That's what the screen reader is going to read, is the label text. And so if those things are not associated properly, then the test will fail. And if you write your test that way initially, and then somebody comes in and makes a typo with the IDs or something to break that association, then your test will break as well. If you're using labeled text, but if you're using IDs, it doesn't break. So following more accessible conventions rather than IDs will make your applications more accessible, and it gives you more confidence. Your tests are resembling the way that users are using your app, because the user is never going to find the input with the data test ID of hello world. They're going to find the input with the label hello world.
So I think the next one is going to be the last question for today, unfortunately, because we are running out of time. So what are your thoughts about using a headless browser for end-to-end testing?
I think using a headless browser is fine. So Cypress actually uses a headless, like during CI, it uses a headless version of itself for testing, and that's a practical way to do that. So like all the browsers have a headless mode now, I think. And so yeah, that's like the practical way to do that kind of testing. With Cypress, it'll even record the screen, even though it is headless. It can still give you a recording if the tests fail, which is really, really awesome. So yeah, I think it's great. Because this was the last question, I'm going to add that if you have any more questions, I have an Ask Me Anything on GitHub. It's kentsydodds.com/AMA, and you can ask questions here, and I will answer them either on my daily 3-minute podcast or on my daily 3 mins, or I do a live stream and a podcast every weekday. So I've got 3 minutes with Kent and Dev Tips with Kent on my YouTube channel. And you can go check if you have any other questions that I didn't get to. You can look at the questions or the other existing answers on there. And if it's not there, then you can go ahead and ask your question there. Also, I'm on Twitter at kentsydodds. So pretty accessible.
So I will ask Ken to send me all those links. So those will be attached to the email with the recording. So don't worry if you didn't get a chance to write them down. I will make sure that you get those so you can contact Kent following up on this webinar. And I really want to thank everyone for joining us today for this live session. And of course, thank our expert guest speaker, Kentsy Dodds, for this incredible, insightful presentation. Again, the recording plus all the links will be sent to you by Monday. And I do hope to see you all at our next event.
Thank you.